This conference will now be recorded.
All right, good morning. Okay, so now what we did in the last session was just understood the basics of Docker, right? So what is Docker, or basically what is container? And we were just trying to understand from a very high level, how does container work and what is the architecture of container and some of the basics of Docker, okay? And we also understood the architecture. So now if you want to work on Docker, you need to basically install Docker in a machine in which you will be having a process running on the background. Okay, I'm just muting everyone for some time. And you will also be having another process. Sorry, there's a background process called daemon, and there will be a CLI. So using this CLI, we will be able to create our own containers. So in that, the first stuff is we will take certain registry and images which is already available. So using that, we will try to see how do we create containers. So that let's basically first understand the concept of containers and Docker. And then we will get into the part of creating our own image or managing the orchestration. But that will be part of a separate module as we go through. Okay, because once again, it's Docker is not part of any module as such. Okay, it's completely basic. So that's the reason this week I want to cover more of basics, so that from next week we will be able to start exactly from the other concepts, because here I'm still focusing on continuous development. Okay, so now by saying this, let's first understand the container management. Okay, so what do you mean by container management? That means if a image, that is a Docker image, is given to you on a machine using the Docker CLI and the image, you should be able to create your own containers, start containers, stop containers, or delete containers, or access something from that containers. So that is the whole concept of getting familiar with containers. That is what I'm calling it as container management. Okay, so now practically, whether you are going to do a development work or a testing work or a deployment, you need to do something like this. But where are you going to do? So ideally you need machines, right? So now when you go to an organization, definitely you would need machines. Now you will not be doing everything in your laptop. Okay, so your laptop is just a starting point from which you will be connecting to different servers or machines. Now this is when all the organizations have started moving towards a cloud infrastructure, which is where rather than having physical machines, they are trying to have machines on cloud. So in that way, for all our practices, I'll be using AWS as our service provider in the cloud. Okay, so all those machines, whatever infrastructure that we need for us to practice and demo, will be available in AWS. So that is where now, even when you go to a company, you should be able to work in a similar way. Okay, so I don't want you to install anything else on your laptop other than only the Gitbash or the Git. So basically, if you have installed Git, whether it is on your Windows or in your Mac, you would have got a CLI. Preferably, if it is a Windows, then you should have got something like a CLI, okay, or what we call it as Gitbash. So this is the only thing I want you to install on your laptop. Other than that, for every other activity, we will create a machine or an infrastructure in AWS, and we will work on that, so that you should be familiar with the cloud also side by side. So that if someone asks, where did you do all these things? You can say, I have used AWS machines, which is what you will be doing in a company also. Okay. So now for us to even work on this, I need a machine. Okay. So basically for all my demo purposes, I'll be taking Ubuntu as an OS. Okay. Now, when you go to a company, It can be Ubuntu, or it can be CentOS, or it can be Red Hat. So it should not be a problem for us. But the reason why I choose Ubuntu is it is quite easy to use Ubuntu. And when you are trying to install whatever the softwares that we need, it will be very simple, like how we do it on Windows. So that's the reason I also want you to start using Ubuntu. And what I want you to do, the next thing is, whatever the commands and steps that I follow, please follow the same way for the first time, so that you will be familiar with the concept. And later on, you can try exploring different things. Okay, so I don't want you to waste your time in exploring something right away. For example, if I say that create a machine in AWS and the type of the machine should be Ubuntu, try doing it. Maybe sometime you will try to install Docker on your laptop directly using a VM, or if it is a Mac, you might be trying to install and spend time. Now, I'm not saying do not explore, but do it after you have completed what we have done. So this way, you will be able to cope up with what we are doing. And I want you to learn everything in the easiest way. Okay. And then when you try exploring it on different machines or based on your interest, then it'll be good for you to learn more. Okay, so that way, what is the simplest way that you can learn the subject and get to a point of whatever is needed for you to start exploring opportunities outside? That is what the whole point that we want. So please try following in the same footstep. Okay, so from now onwards, anything that I want to work, I would be creating a machine in AWS and I'll be working on that. Okay, and I believe everyone will have a AWS account with you, but just in case if someone do not have a AWS account, just ping me a little later. Okay, I'll just give you some steps where you can create your own free tier account in AWS. Okay, so AWS gives us something called as a free tier account, which you can use it for 1 year, but there is a catch in which you can use only certain services for free. And suppose if you take a machine, every month you can run machines in AWS within 750 hours. Okay, so you definitely do not use beyond 750 hours. But additionally, for certain use cases, we might need to take some machine in AWS, which will be costing, not less than $1 or $2 for you maximum. Okay, I'm saying for a month. So other than that, you will not be charged anything more, because for few things like Kubernetes or some advanced projects, when we want to do, the free machines which AWS gives us will not be sufficient. Okay, so that's the reason in those cases I'll let you know. So what you have to do is create some machines, practice, and stop it. Okay, and one more thing what you have to remember is, after you do your practice, make sure you stop all the machines in AWS, because if you keep running the machines, the 750 hours will be easily completed. And beyond the 750 hours within a month, if you use, they will be charging something. But again, it will be less, but unnecessarily you should not be charged. So whatever you do, practice and stop the machines immediately. Okay. So just keep this in mind. So this way, no, if you're stopping, you won't be charged. So AWS will charge you only for running machines. So that is the reason. Assume if you create 10 machines and you just left it for 3 days or 4 days, then what will happen? Each machine will be taken 24 hours a day into 10 machines easily. In one day, 250 hours is gone. Okay. So like that. So it is not just one machines, a total of 750 hours per month is what given to you. Okay, so anyway, this is the first day, so I'll just walk you through how do you create a machine. Even though if you know, just try to familiarize. Now, when you log into AWS, in AWS there are different regions, which is nothing but what we call it as availability zone, or in simple, these are called as data centers. Just like how in your company there will be different data centers. Now what I want you to do is, as soon as you log into AWS, over here on the top right, you can click on this and choose a region which is close enough to you. So this way, whatever the machines you are creating will be created in the AWS in a region closer to you, so that when you access the machine and work, it will be faster. Now, for those who are from India, you can choose the Asia Pacific Mumbai region. But someone, if you guys are from US, and try to see which region of US and try to choose the region accordingly. Now, for those who are from Canada, you can try using CA Central or any other region which is close enough. Okay, the reason why I'm saying is I can also create a machine in Hong Kong or US East. But what will happen over the network, if I'm trying to connect from Bangalore to here, then the operation, whatever I do, will be slow, right? So that's why always choose a region close to you. So this is what you have to do once, that's all. Once you choose, thereafter, whatever the machines and infra that you create, everything will be under this region. Okay, next, click on the services and you can see something called as EC2. So under the compute, click on EC2. So EC2 is the service name using which we will be able to create machines in AWS. Okay. Now over here, this will tell you if there are any machines running. Okay, so right now you can see it says running is 0. That means in my account in Mumbai region there is no machines running. So what you can do is you can also cross check. Okay, so over here what we can do, you can see there is nothing running, but however if you just clear, I can show you that already these are the machines which I have created, but they have stopped. So whenever I want, I can stop and start a machine just like your laptop. Okay, so since we are beginning from the scratch, now when you want to create a machine, click on launch instance. Okay, an instance is nothing but a machine that you're creating. Now, the first step that you have to do is choose an image for your machine, which is nothing but the operating system. So the machine that we are going to create in AWS. So what is the OS that you want inside it? So that has been given by an image which is available in Amazon. Okay, that is what we call it as AMI. Now, since I said it's Ubuntu, so quickly search for Ubuntu and take Ubuntu 20, which is latest. Okay, now this is where if you have created the free tier account, the only machine which is eligible for you to use is a type called T2 micro. So using this, you will be getting 1 CPU and 1 GB RAM in that machine. So that way you can use 750 hours of this machine. So you will not be charged until that. But if you are trying to create any other machines because of more capacity, then this will be charged. Okay, so go ahead and use T2 micro as much as possible. Now click on next. Now, how many machines do you want? Right now, I want only one machine, so I'll leave it and leave everything default, because when you create a free account in AWS, AWS will create a private network for you by default. Okay, so that's the reason for your practicing, you don't have to create. But when you go to a company, there should be a separate network created, and that is when, if you are an administrator, you can also create. If not, you can also ask someone else to create to you and you can start working. But for us, when we create a free tier account, there will be a private network which is already created, and that is what we are going to use. And that network in AWS is called as VPC. So for my account, there is a VPC or a private network already created, and that is what I'm going to use for all my demo session. Same way, when you log in, leave everything to default. So unless and until you're not familiar with networks, don't do anything. So just use the default. So even if someone asks, you can say that there was a default network created or a default VPC created for you. You have used it, or there was a separate VPC that you are using it. Okay, so go ahead and say next. And when you create a machine in AWS, it gives you by default 8 GB of RAM as a hard disk. Okay, so this should be sufficient, but whenever we need, we can increase it. So go ahead and next, and leave this. You don't need any tags to be added, and come to security group. Now security group is like firewall. Once again, when you create a account along with the private network or VPC, you will also be getting a default firewall. So okay, I want you to start using it for all your practice. And again, remember, in a company you can have everything separate, but for now use default. So click on this default, okay, and review and launch. And finally, this is what it is telling. You just cross check whatever that you wanted. And this is the security group what I had, but I'll tell you what and all you have to add in this. Now go ahead and say launch. Now when you say launch, what happens is it will be asking you for a key pair. So key pair is like a password using which you will be connecting to the AWS machines. Okay, so for AWS, when you're connecting to a machine in AWS, unlike the regular machines, you will not be using the password. Instead, there will be a file called as PEM file in which we will be having the key, which is what we are going to use. So for that, when you are first timer, then you need to create a key. Okay, so then choose this and say create a new key. Okay, and give some name for the key. So I'll call this as DevOps. Okay, and click on download. You can see there's a file called devops.pem downloaded. Now just leave this. So going forward, if you are creating a new machine, then what you should do is click this and say choose an existing key pair, and then it will be showing you all the keys available. So you can just choose the key that you created and then continue. Now this is the first time, so I'm just going to choose this key. So click on launch instance. Okay, so there's a new machine getting created. Now if you want to cross check, go back to services, compute EC2. So just wait for a couple of seconds and you should be getting your first machine created in AWS. Okay, now click on running instance. It depends on your network. Sometimes it might come in 2-3 seconds, or sometimes it will take 15-20 seconds. You just wait for some time and it should come up. Okay, now let's wait for a few seconds because, okay, anyway, it came up. So you can see that there is one machine that is created and it is running, and you can see the details of this, where it is available, what is the DNS and other details. Now quickly, as we are going to have many machines, you can now tag it. Okay, so here click on the name and give some name so that tomorrow if you have multiple machines created, you will be able to identify. So I'll call this as Docker host. Now here, whenever you are trying to connect to a machine in AWS or any other services, the security group or firewall will be applied. So you should be telling what kind of connections is allowed to reach the AWS machine or other services. So for that, in the same EC2 dashboard in the console, if you just scroll down under network and security, you will see security group. So click on this. Okay, so you can see here I have created a security group for my own purpose, so ignore it, but there is a default, right? So click on this default. Now in the default, okay, let me just maximize or zoom the screen. So you should see something called as inbound rule. So in the inbound rule for you, you will not be having all this. So click on edit inbound rule. Okay. Now what I want you to do is, I want you to first add a rule here, and in this choose SSH. Okay. And in this custom box, give 0000. So the meaning of this is, from any IP address, you can connect to a machine available in AWS. Because whenever you are connecting, if you are connecting to a Linux machine, you will be using a port called 22, and that is what you are allowing here. So the meaning of this here is, if you want to connect to any Linux machine in AWS, when you are doing SSH, port 22 is what it will be connecting to, so that you connect. Because in a company, we can also choose from which particular IP the connection should come, which should not be connected. But since as of now, you are connecting from your laptop, so there is no concern. So just go ahead and just say 0000. So that means from any machine I can connect. For example, if I have another laptop, from that laptop also I can connect and show you the demo. So I don't want to restrict. So that's the reason I'm leaving it as 000. Okay. And the port is 22. Like this, going forward, if we have any application running and if you want to access, then there will be a port corresponding to it which you need to enable. So what I want you to do in the same way is, along with port 22, okay, now we will add a rule, and I will say custom TCP, and I'll say port 80. Okay. So whenever I need, I'll be adding. Suppose if I'm running some applications like Apache or Nginx, they will be running on port 80. So if I want to access them, then I have to put this 80. So for now, keep these two things, should be good. Okay. Now, like this, you can already see that I have added a port for 8080, 9090. So whenever it is needed, I'll let you know. You just have to come back and add it. So the most important one right now is, when you begin, you need SSH, which is port 22 and 80. Okay. Now, once you have added, go ahead and say save rule. Okay. This is there. Fine. So now we have added the rule of 22, which will allow me to connect to my machine that we have created. So come back. Okay. So now how do I connect to this machine? So whenever you want to connect, now choose this machine. Okay. So once you have chosen, this box will be clicked. Now come to this connect. All right. Now just in case, if you want to stop this machine after your work, then choose the machine, come to instance state and stop. Okay. So if you want to restart the machine, reboot. You don't need to reboot every time. But if you say terminate, the machine will be deleted. Okay. So right now I don't want to terminate or stop, but at the end of the class, what I will do is stop it. But tomorrow when you start your day again, then choose the machine and then just say start. So suppose tomorrow I'm taking your class, which is not today, tomorrow, Monday, then I have to just say click on this machine and start. Okay. So now all I have to do is, the machine is running, so I will just say connect. And to connect to a machine, I can actually use this easy to connect, and I can click on this, and without a console, it will be directly connecting. Okay. So you can just directly say connect, and you can see there is a console which is getting connected, and you can use this to start working on the machine. Okay. So this is one console. Okay. Suppose if you don't have Gitbash, it's not a problem. you can directly using this console to start working. Okay, so you have connected to your AWS machine. But another way that you can do is you can connect using the SSH client. So for that, go to SSH and you should see that there is a connection string. So click on this and now go to your machine in which you have the command prompt or the git bash available. Now for those, how did I come to this git bash? Now I've already installed git in my machine. So if I just scroll down, you have git and in that you have git bash. So if you click, you will be getting this. If not, I can quickly go and search for git bash executable and it will open that. Okay. So this is how we can quickly open a git bash command prompt on your Windows. If you are already on a Mac, you don't need anything. Okay, you can just start running the commands directly. So only for a Windows, you need a command prompt which works like a Linux box. Because if you want to connect to a Linux box, you need a command prompt which will allow you to run SSH. So by default in Windows, that is not available. Hence, I will be using this git bash, which acts as a bash. So bash is a Linux command prompt. Okay, because by default in Windows, what you are going to get is this command prompt, which is called as Windows command prompt. In this, sometimes your SSH might not be available if you have not installed by default. So that is where always try to use the git bash to connect to a machine. Okay. Now, here, if you remember, I downloaded my PEM file. So that is available in the downloads folder. Okay. So in your laptop, whatever you download, it will be going to your downloads folder. So now just cross check that. So you can see that it is available. Okay. So all you have to do now is, if you go back to AWS, it would give you a command called chmod 400 ops. So which means it's saying change the permission of the file. So copy this and try to run this here. Okay, so first I've just changed the permission. To cross check, you can just say this. So you can see it's 400. Fine. Now make sure you're going to the folder where you have your PEM file downloaded. And from here, what I want you to do is now copy this and execute the command. Okay. This is a new laptop. It's not copied. Okay. So the command that we are using is SSH, which is a secure shell to connect to a Linux machine. And this is the username which is created by AWS. And this is the machine's IP address that we are connecting. So whenever you are going to do SSH, the command is SSH, the username @ machine name. So when you try to run this, it will be asking for password. So that is where instead of asking for password, we are using -i and the PEM file. So take this key as a password. That is what we are trying to tell. And now watch this. When I enter, now in this, if you are getting an error message saying unable to connect or SSH connection failed, then if not, if you get permission denied, then that means on your security group, you have not allowed port 22. Because from this machine, when we are going to connect port 22 of the AWS machine, that is where the security group has been allowed to let us in using this port 22. Now here, go ahead and say S. Okay, so now you can see this command prompt is connected to AWS. Now this will be called as a terminal for us, so that I can now connect, type everything. So who am I? Ubuntu. And to cross check, if I say cat etc os release, so it says I'm working on a Ubuntu 20 machine. And to show you the next things, if I can say df-kh, so this machine has close to 8 GB of hard disk. And if you just go ahead and say free, and it gives you that it has around 978 MB of RAM or 1 GB of RAM. So this is the machine that we created in AWS, and we are able to successfully connect. So this is how I want you to do all your work. Okay, so create a machine, connect to it using SSH. Okay, now when you are connected to a machine, you have connected as a default user called Ubuntu. Sometimes, or most of the times, when you connect to a machine, the regular user or the normal user like Ubuntu doesn't have administration privilege. So what you have to do is you have to switch the user to root, and then anything that you want to do as an administrator, like if you want to install a package or stop some software or stop some service or start some service, those kind of things cannot be done as a regular user or Ubuntu. So at that cases, you need to switch as a root user. For that, use this command called sudo su. Okay, anyway, I'll start making a note of that. So the first thing you're going to do is do a sudo su. Okay, let me just save this. Let me know if this is visible or you want me to increase the font.
Adam, I have one
It's
question.
visible, Adam.
Can you please
Yep, go
increase
ahead.
the font?
Yeah, I'm doing that. Oops, this is not good.
Can I ask you one question?
Yeah, go ahead.
Yeah, regarding this AWS in our companies, generally we'll create a machines on the cloud instance, or generally we'll work on the laptop which we got
No laptop.
assigned.
You cannot work everything in your laptop, because your laptop will not have every resource needed. So obviously you will be connecting to different machines and you will be working. So your laptop is just for you to connect to those machines in the company also. Getting it? So that's
Yes.
whatever we are doing, it's the same thing that you want. Okay, that's the reason I'm saying follow that. Is it visible now?
Yeah. So Adam, Sushant, so I have one question.
Yeah.
Adam, that security group that what you told, that that security group will be created by a network team, or we have to create, DevOps team has to create any security group?
Okay. So this is where if you are going as a DevOps engineer, obviously it means you know certain things. So this is where if your team knows how to do it, then you can request an access and you can create a security group. But let's assume that you are not going to take care of that, then you can ask the separate AWS admin team to create a security group for you and start working. Now that is where creating a security group is not a problem. So once you know it, you can start taking up the responsibility of that. Okay, so that's where. In the beginning, someone has to create and give it to you, but going forward, once you know, you can go ahead and create it or modify it by yourself.
Okay. And one more is that
Mhm.
how much space one server needs, and what all things we have to deploy. It will be having some specific release note, or by default we have to take care, or DevOps team has to take care.
For what? Creating a machine?
Yeah, creating a machine, how much space we have to allocate, and what all things we need to configure, how many instance we need to configure. It will be mentioned in any release note, or DevOps
It is
team has to take
not.
take to decision.
It is not in that way. So that is what. See, now there are different teams who will be using AWS for different purposes. Now, being a DevOps engineer, you need to know what and all are your responsibilities. If you are going to help each and everyone in the organization to set up a infrastructure, then you are focusing more as a role on AWS administration or site reliability. Okay, so if that is your
Yeah.
work, then you need to work with each of the team, understand what is that they need. Then, for example, go to a product team and ask them, okay, how many developers are there? How many machines do you need? What is the capacity of each machine that you're looking at? So that way you need to work. Same way, if you're setting up a QA environment, then you should go to each and every team in QA or whoever is approaching you and help them understanding if they are running their application, for that application what capacity is needed. So basically everything has to be given by them, right? So it's like you go to a shop. Will the
Correct.
shop owner give you a laptop just like that? So he will ask you what is your spec, and I will suggest you what are the models available, and close to that whatever is there, this is what you can take. So that way, if you are doing site reliability, or if you're taking care of the core AWS administration, input will be taken from the users. However, in the DevOps other side, if you are automating certain things for your work like CI/CD or deployment, then you will be knowing what you are deploying. Once again, you should have been working with developers in QA and you know what is the requirement. So based on that, you can create a machine by yourself. So that is how.
Okay. Okay. Thank you, Adam. I got it.
Madam, one doubt. Previously, we used to connect using PPQ file, but here you have not used it. Is it not required now?
No, you don't need that. That is when if you're connecting from a different tool, like if you're using Putty or something else as SSH client, then you have to convert this file. So right now we are trying to use it in a native format. Okay, so directly we are trying to connect using the same SSH command itself. So that is the reason I'm not converting anything. It's basically making it simple for you. You don't have to convert.
Okay.
Adam, is it because of DevOps.pem file it is not asking root password, or how it will be?
Exactly. Instead of password, you're specifically given this PEM file. That
The
is
PEM file
what is
contains
acting as a
root user password also.
that is, yeah, it's not a password. It's a substitution of password, which is the key.
Okay.
Okay. So now once you log in, switch the user as root. So you can see now I am not as Ubuntu, I am as root. So anytime if you want to come out, you just say exit and you will be back as Ubuntu. Okay. Now first switch as root. So you can see I am as root again. Who am I? Root. Okay. Now, this is where I want you to first install Docker. Okay. So to do that, you need to first run a command called apt update. Now, since we are trying to use Ubuntu machine, use this command called apt, which is called as the packaging manager. And now anything that I type using dollar indicates that it is a command. So I don't want you to run or type the dollar also. Okay. So going forward, understand this is again just a naming convention. Dollar is representing the command here, okay? So that you know whatever I'm typing is a command or some notes for you to refer. So this is a command, which is something similar what you see here. So here, go ahead and say apt update. Now this will update all the libraries in your machine. Okay, once this is done, the next thing what I want you to do is apt install -y docker.io. So this is the name of the package to install Docker. So when I say package, remember it's a collection of files. So this will have the Docker daemon process and it will also have the Docker CLI. Both of them will get installed in your machine. So go ahead and then run this. Now again, for running all these things, you need to be as root user. Okay, so I'll just clear the screen and go ahead and run this.
Adam, like, is there any difference between executing this docker.io and there is a specific document in the Docker community, right? It has certain steps. How that makes a difference between these two?
Steps varies from OS to OS. Okay, so that
Okay.
is where in Ubuntu it's very simple. If you just run docker, sorry, apt install -y docker.io, it will get you everything. So that's the reason I'm saying that use Ubuntu for all your practice.
Okay. Yeah. Thank you.
Yeah, Adam, when you specify the security group inbound rule as ultra vague, do we still need to specify SS port there?
Yes.
Okay.
Yeah, this work on CentOS. It doesn't matter. Okay, CentOS, Red Hat, Ubuntu, everything it'll work, but it'll be easy for you if you start using Ubuntu. Okay, so now once Docker has been installed, then if you just type which Docker, it's going to be user bin Docker. Okay, and what is this? This is the Docker CLI that I was explaining you. Okay, and now the question is, where is the Docker daemon? So now after you have installed the package of the Docker, you need to start the Docker daemon. Okay, now this is where if you take other OS, there is one more step that you have to run in which you have to start it. If not, in Ubuntu, this is what the command that you have to give. But instead of giving this, what the Ubuntu will do, it will automatically start it. Okay, so when you did the install, that is apt install, automatically the Docker daemon is also being started by the Ubuntu. So that is where there is no two steps. Just to cross check, you can say systemctl status and you can see this is there. But just in case, if you are restarting a machine, then if Docker is not running, then what you should do is after executing this, you should just say systemctl start Docker. And to cross check whether it is running fine or not, you can just say status Docker. Okay. For some reason, I don't like this font. Oops. Okay, let's not play around with it. Anyway, cross check whether it is running, and going forward, if you want to access Docker, all you're going to say is the command called Docker. Now, what is this? This is the Docker CLI, which is nothing but here. Okay. And what is this process which is running in the background is the Docker daemon. Okay. You can just say Control C over here. So now we have installed Docker and the Docker daemon is also running. So we can just start using the Docker CLI to communicate to this Docker daemon. Okay.
I have a query. The commands for Red Hat, CentOS, and Ubuntu will be same.
No, it'll vary. So if you go to the docker.io website, you will be having different commands. Okay, so that is where I don't want you to explore anything as of now. So just get used to Ubuntu. So it'll be very easy. It's all about just one command. If you run, all those things will be there. But if you go and find out the installation step for Red Hat or CentOS, definitely it'll be a little different. So if you're not familiar with working on Linux, I don't want you to explore all those things now. Okay, so that's the reason
So
I'm just
in
saying.
companies, they will be using Ubuntu only. Like
Yeah,
we
they
can
can
say that.
see. It depends. We cannot just say like whether I'm going to use Samsung or iPhone. Everyone should not be using it. But for you to practice, this is the only thing needed, right? See, when you go to a company, let's assume they are not using Ubuntu. They are using CentOS or something else. The only difference that you just have to do at that time is, okay, do you want me to start working? Okay, I have to install Docker. Let me just find out what is the step. So you don't have to literally remember anything. But the whole concept that we have to carry back is, are you comfortable in working with Docker? Do you have hands-on experience on Docker? Do you know how it works? Just like how I said, I've been using Samsung phone from a long time, and suddenly if someone says that, okay, start using iPhone, does it mean that I don't know how to make calls or I've not used the phone? No, it's just that I've been using it for a different flavor and I'm just getting used to a new one. So that is how I don't want you to worry about that. Okay. So installing those are very small commands that you can do it anytime. But the focus after installing what you're going to do is what we will be learning. Okay, so this 3 commands, 4 commands will vary from OS to OS.
Okay.
And moreover, Adam, in the organization, we don't get the pseudo privileges, right?
You will
So
get. If you are a regular user, you will not get. But ideally, as you are going to do a lot of stuffs and automation, definitely if you say you are a DevOps engineer, you would need sudo privilege on that because you own this machine, right? If you are the one creating the machine, obviously you will get every access. That is for developers and QA, where if you're just accessing the machine to run some application, you don't need. But when you are going into a responsibility where you have to create the machine and configure, definitely you will need it. Okay.
thank you.
Yeah. Now, one more thing, what you can do is give the command called docker info, and this will also show you whether your Docker client is communicating to the Docker daemon. So now if you get this output, this means you can cross check and say that the Docker daemon is working fine and your current machine, you don't have any containers. Okay. So that way, if you get an error here, that means your Docker daemon is not running. Then quickly go ahead and use the systemctl and check whether the Docker daemon is running. If not, start and then run it. And one more thing, I have installed Docker as root. So I'll be running the Docker as root. So if you try to run the Docker client using any other user, as of now, it will not be allowing. For example, come out, the same command, if I say here, you can see it says permission denied. So this is expected. But if you get the same thing using root, then cross check whether your Docker daemon is running. Now I'll tell you how you can run it as Ubuntu user a little later, but for now get familiar with certain root things. So once again, switch as root, and now I can run this. All right. So this is all about installing Docker, wherein this is the Docker CLI. Okay. So we are done with our installation of Docker, which is nothing but just 2 commands, and you have to start working. Now this is where, as a normal user, whatever that we are doing, we will be doing. Okay, this is just for our understanding to know other things. So when you are trying to work on Docker client, then you will be using the CLI called Docker. So what is this? This is the Docker CLI. Okay. Now, for us to create a container and work, there are different commands that we will be using. For example, if I want to create a new container, okay, so it is like a new machine. So first you need to create a container, start the container, and you have to log into that container. Okay, so instead of doing all those things in separate commands, there is one command called docker run. Okay, and what will docker run do? So docker run will create new container. Okay, so it is like an empty box it will create, and for every new container we are going to create, a unique ID will be assigned. So what do you mean by unique ID? So when you are creating containers, all these things are nothing but process. So how do you identify them? Using this unique ID. So every time when you execute docker run, you will get a new container, and inside that, whatever that you have told will be running, and it will have a unique ID. However, after this, the container will get started. Okay, start the container. Okay, just like a machine, you create a machine and then start the machine. And the third thing is we will attach to the container. Okay, now before I jump into this, when I say I'm creating a new container, if you remember yesterday I was telling this container is nothing but a process. Now practically I cannot create an empty process. So that is where I need something to be running inside the process. Only then it is called as process. So what is that I have to run? Now that is where the environment that we were deciding what to run should be there. So that is where for us to create a container, you need the image, which is what we call it as Docker image. So when you are trying to create a container, it is mandatory that you should tell from what image the container should be created, so that it will create an empty box and put the content of the image copied into it, and that is what will be running. So that is where whenever you say docker run, you also have to say a docker image name. Okay, now when you create this container, the container will be empty, wherein the docker daemon will put a copy of that image inside it, and that is what it will be starting. Okay, so the first option that you're going to give for this is the image. But the question now comes is, if you go back to this diagram, so this is the CLI that we are using, and I'm trying to run some command, but I don't have any images in my machine, and the images are available in some location called Docker registry. So this is where first either you have to download the images to your machine, and then you should be executing the docker run command. If not, when you execute the docker run, the Docker CLI will check whether that image is available in your machine. If not, there is a default registry available. From that default registry, it will be downloading everything. Now, what is that default registry? Don't worry. For now, just remember this. When you run or when you execute the Docker run, if an image is not available on the local machine, it will go to the default registry, whatever it is, and it will try to download it automatically, and then it will create the container for the first time. Okay, so that way, since we don't have any images, if you give an image name, then it will check whether that image is available locally. If not, download from Docker registry. And right now we are using the default registry. However, we can also have a separate registry for us and we can tell to pick from there. Okay, now these are the things that will happen. Now, this is where what are the name of the images. So there are different images available. Now, just to show you the initial demo. Now, since I'm working on Ubuntu machine, to show you the difference, I can have host machine as a different OS, and inside the container, I can have a different OS because the image can be from a different OS. So this is where for change, let me use CentOS. So this way now if you see, if your application needs to run on CentOS, then take the image of CentOS and the host machine, you can still run it on Ubuntu or Red Hat. It doesn't matter. So that is how for your application to run, which OS is needed, you can take that as the image. Okay, because if I want to share the same thing to you, regardless of whether you have a Mac or a Ubuntu or Red Hat running, in which Docker is going to just create this container. Okay, so when you execute this, Docker daemon will download the CentOS image from the default registry, create a new container, assign a unique ID, and it will start the container. Okay, so these things will happen with one command. Now finally, once the container is created, now container is nothing but a process. So where is it going to run? It will be running inside this machine. But if you want to connect to that, how will you connect? So that is where it is not a machine to which you will be doing a SSH and connect. It is a process within the same machine. So that is where we want that process to get attached to this terminal, so that now if you see, if I say host name, I am actually on my AWS Ubuntu machine. So when I want to attach to the container, then you will be working inside the containers process. So that is how if we attach to that container process will get attached to the same terminal, so that you will feel as if you are working inside the container like a separate machine, but it is just attached to the same screen. Okay, so to do that, when you are creating a container, then you can just say an option called -it. So -it represents attach your current terminal to the container interactively. Interactively means as soon as the screen gets attached, whatever you type, the container should be receiving it, right? Because right now, do you see that the screen is interactive? Yes, because whatever the command I type, it is showing me. The same way you want the container also to respond to you. So that is where we will say attach interactively. So if you say attach to the container interactively. So since this is the beginning of the Docker, we will use lot of using interactive. Now there are different options also. So now watch carefully what I'm going to do. So I am on my host machine. Okay, just to show you the difference that you are inside the container, I'll go to the temp folder. Okay, and on my host machine, do you see this? I will create a file called host. So now you can cross check that on my host machine, which is Ubuntu, I have a temp file, sorry, a host file under temp. Okay, and the IP of my machine is this. I can cross check here also. Now see what happens when I execute this command called docker run -it CentOS. So it is saying there is no such image called CentOS locally. So it is trying to download from where? The default registry. Okay, so it's automatically downloading it. And once it is downloaded, it has created a container, started the container, and in fact, we have also attached it to the container. So where am I now? If you see, I am inside the container, not on the host machine. Okay, how can I cross check? First thing, do a host name. What is it saying? This is the unique ID of your container. This is not your host machine now. Remember, inside your host machine, there is a process which is nothing but container. Now you are inside the container. And to double check, if I now say the same etc release, what is it saying? CentOS. So you can see now on my Ubuntu, there is a process or a box which is being treated as a CentOS, and we have attached it into it. So that is how your host machine can have something, whereas your container can have something else. Okay. And okay. The next thing is, when you go to the container, it is isolated. That is what yesterday we were understanding. So the meaning of this is, whatever you do inside the container remains inside the container, and it is not at all attached to your host machine. So by saying this, you have to now understand a container will have its own file system. Okay, so what do you mean by file system? Just like in Windows, you have your own C drive and D drive. When you create a Linux machine, it will have its own root folder. Okay, that is what we call it as file system. Same way, when you create a container, now this container has CentOS and this has its own file system. Okay, and anything that you store inside this file system of the container will not be visible to your host machine. So now I am inside the container, the temp folder of it. Do you see? This has only 2 files. Whereas if you scroll up, this was the temp of your host machine. So that way you can understand, inside the container you are not at all seeing anything from the host machine, because your container itself has its own file system. And if I create some file here inside the temp folder in container, if I go back to my host machine, you should not be seeing, because anything that you put inside and run inside the container is within the container. Okay. Now, if you want to go back to your host machine, you just have to say exit. So when you say exit, now you can see you are back to your host machine. So if I say host name, it will say this is the one. Okay, so you're back to your host machine. And if I now go to temp in this, do you see that container file? Nothing, because this was inside the container, whereas this is on the host machine. So that is how you create a container and everything will be contained or encapsulated. It will not be available on the host machine. Okay. And every time you execute Docker run, a new container will be created. Okay. So just to show you that once again, now the previous container ID was something called 83FAE. Just remember that. What happens if I rerun this command now? So once again, if I run this, it didn't download because there is a CentOS image in my machine already available. So using that, it is just creating one more copy of the container. And you can see this is a unique ID, which is nothing but a new container. And this is also CentOS. So it's just going to create a copy. That's all. And if I go to temp, this is new. Everything is new. So that is how every container is new when you say Docker run. Okay. And every new container will have its unique ID, and anything that you do will be only within that. Okay. So this is the basics you need to know. Every container will have its unique ID. Anything that you put inside a container will have its own file system, and whatever you store in the container remains in the container. Okay. And by default, the container will be getting all the resources from the host machine. So now if I just type this, the same df-k. So you can see whatever the 8 GB available in the host machine is also available for your container, and the same way whatever is the RAM which was available to you on the host machine is also available inside the container. So whatever is there by default, it will give you everything. Okay. Now, so when I say exit, what happens is your connection is back to your host machine. But what happened to this container? So this is where whenever you say exit, the containers will get stopped. Okay. So at any point of time, if you want to know how many containers are available in your machine, then you can say docker ps. But the meaning of ps here is process. See, in a Linux machine, if you type ps, it will show you what are the live processes which has been executed by you. Okay, so you can see we did a sudo, we did a bash, and just now I executed a command called ps. So this way, if I say docker ps, it will show you if there is any live container or if there is any container currently running, because if a container is running, that means there is a process running on your host machine. Okay, so that way right now when we did the exit from the container gets stopped. So that's the reason you do not see anything running. But if you want to see every container which is available, whether it is running or not running, then you are going to say ps-a. So now you can see these are the two containers that we created, but they are in the exited mode or stopped mode. Why? Because we came out of it. So when you came out of an attached container, the Docker will just stop it. It will not delete it. Okay, so these two containers are available in my machine, but they are stopped. So to check whether you have some active container running or not, you can just say docker ps, but ps will show you only the live containers or running containers. So if you say ps-a, it will try to show you all the containers which are available. If it's a container deleted, you will not get it back. Okay. Now, we just saw how do we create a container and how does it get attached to it. But practically, if you see, you are not going to just keep on creating the container. At any time, just like a machine, you should be reusing a container. So if you want to reuse a container, you want to go back to the same container now, right? Because I have two containers. What if I want you to go back to a container? Now that is where, if you have to go back to a container, you need to start the container first. But for that, you need to remember the unique ID. See, right now there was only two containers, so easily you know what was the first container and what is the second container. But after 2 days, if you come back and if I ask you, hey, I want to go back to a particular container or I want to start my container and reuse it, then remembering the ID will be difficult. So that is where when we create a container, we will be giving a name. Okay, so you can give a string as a name to uniquely identify your container. So that option can be given before this image. So somewhere here, you can just say hyphen name, and you can just say container name. Okay, and the same example if I put here, I can just say hyphen name. Let me just call it as test 0. Okay, so now watch what happens. Let me clear the screen. Docker run hyphen name. So I can give -it first or name, both are there, but all the options should be before the image name. So I can say test 00 -it CentOS. Okay, so I'm inside this and you can see there is a new container ID. Now let's go to temp folder and I'll create a new file. and so you can see inside the temp folder in this container, I have a file created and this is the ID. Now when I do exit, the container gets stopped. Okay, and this file will not be available on my host machine because whatever I did is specifically inside the container. Now don't worry anything about what applications you have to run. First, let's get comfortable with using containers and then we will see what and all you have to run inside. So here, I just came out of the container and it got stopped. So if I have to start my container again, which is available, I should not be using run because when I say run, what will it do? It will create a new container. So that's the reason we should start a container. So to start a container, you can say docker start, and this is where you can give the container name or you can give the container ID. Any one of them is sufficient. Now this is where I don't want to remember the ID, then I can simply give the name. So if you go back, if I say docker start and test 00, this will work. And now if you go ahead and do a docker ps, you should see there is one container running. So getting the difference now, ps will show you the running containers, ps-way will show you everything. So this is how you will know what is running, what is not running in your machine as a container. Okay, so this is only for a container which is stopped, we have started, because if it's a new container you will say run. Now what will happen if I want to go inside the container, right? Because see, the equivalent of this is what here that the run was doing by itself. Okay, so what is the equivalent of this attach? So for that you are going to say docker attach. Okay, and the same way you can give your container ID or the name. But once again, remember this, if you want to execute the command called docker attach, while creating the container, you should have given -it. So you can explore that. If you just said docker run without -it, and then you will, I mean, if you're trying to attach it later, it will not allow you because it will just say that you don't have the attaching possibility. So that's where while creating, you have to give. After creating, you cannot change it. Okay. So now if I go back, okay, in the same screen, if I say docker attach test 00, okay, so you can see that I'm inside the same container, and to cross check, if I go to temp, I have this file. So this is how you can refer to a container using its name also or the ID. But whenever you do exit, it gets stopped. Okay. So if you want to start,
I have one doubt here. Hello.
Yeah, go ahead.
Whenever we are coming out of a container, the container is getting stopped. But in real time, how we are going to do without stopping a container?
Yeah, we'll come to that.
Okay.
And also, can we able to change the name of existing container?
You can change, but that's not the focus here. I mean, you can do it, but as we understand it, right, you are not going to use Docker directly. Okay, you will be using certain things like Kubernetes later, which will be calling. So you have a better way of managing everything there. But underlying, we just need to understand how Docker works, because there are a lot of use cases where without Kubernetes, you can use Docker. Then you need to know all those things. But changing a name will not be a problem for us. Okay.
Got it. Yeah.
Okay. Now, when I stop my container by saying exit, because when I say exit, it is stopping. Now the container is available, but if you want to delete a container, then you can say docker rm and the container name. Okay, so this is where if I just say the name or the ID, it is gone. But remember, when you delete a container, everything inside it is also going to get deleted permanently. Okay, so that is how when you stop a container, you can start it anytime. But if a container is deleted, then it's gone. So you don't have any containers now. Okay. But now the question comes is, okay, why was it doing a stop when I did a exit? Okay, that is the question. But before we go to that question, there is another question that was coming is, I told you that container is a process. Okay, now what is a process? A process is something which consumes some resources on your host machine and something is running practically, a simple way of telling. So what was that running inside my container, right? Because we just created a container, but what is running inside the container? So if you see, let's go back and now try to run the same command. Okay, so we are inside the container, and if you just type this command called ps, you can see the first command that is running inside the container is something called as bin bash. Okay, and bin bash is the interactive shell. That is why whatever that you are typing, it is receiving it internally. Okay, and look at this process ID. So the first process that is running inside the container is this. So as long as this process is running, the container is also going to be running, because process ID 1 is called as the init ID, right? In your laptop, there is a process called init process. So basically, when you try to say reboot your machine, this process will be stopped and started. So that is where now inside the container, the first command that is running is bin bash. As long as this is running, your container is also considered running. And the current shell that you are working is also the same one. That is where it is giving you an interactive shell. So when I say exit, what happens? So basically, you are trying to give a exit command to this bin bash. So when you say exit to a shell that is a bash shell, it will stop working. That is the reason when inside this container, when this bash shell is not working, which is the parent ID, then there is nothing else running inside the container. So obviously the container will be stopped by the Docker. That is why when we were saying exit, automatically the container was getting stopped, because by saying exit, we are stopping this bash, and by stopping this bash, there is nothing else running inside the container, and the container was also getting stopped. Okay, so this is how the exit was stopping the container. Okay, but the question now we have is, who asked to run this with bash, or how did it run this? So that is when, whenever you are creating a container, there should be something as a first command. Okay, and that's where for every container, if you actually see, there will be something called as run command or a first command. So that way, when you are creating a container, you can tell your own first command that you want to run. But as long as that command is running, container will be running. Okay, so you have to choose wisely what is that command which will be running always. So now, if you do not give your first command, then whoever is creating the image, we can create an image in such a way that a default command can be passed. That is how the CentOS image that we are using, whoever have created it in such a way that bin bash will be the default command to run when you do not say anything. Okay, so that is when, so far when we were creating the container, automatically the default command what it was running is bin bash. Okay, and that is where bin bash is an interactive shell. So as soon as we attach it inside it, as long as you type some command, it will be there. But when you say exit, the bash is also stopped and you are also coming out. So what if you want to have your own first command executed? That is when after the image, you can basically pass your first command. Okay. So how do I pass? For example, if I wanted to pass that bin bash, then I can say bin bash here like this. Okay, so now looking at this command, you should be able to say that this is the OS name and this is the first command to run. So when you create a container like this, after starting the container, the first command that you give will be running. If you do not give, then in the image, whatever is the default command which is being specified while creating the image will be applied. Okay, now these are the things that we will explore when we go to the image creation or image management. But just remember this for now. Now, if I go back, the same command, okay, let me just quickly stop it. Docker rm test 00. Okay, now I'll create a new container, and this time watch, instead of saying bin bash, I will say bin sh. So it created a container and we are inside this container, which is a new container. Okay, and in this, what is the first command running? It is bin sh. Why? Because this is what I explicitly given. If I don't give anything, then from the CentOS image, it will take bin bash as default. So this is how you can tell whatever you want. Now, in fact, I can run a shell command, Python command, or I can run a application script, whatever I want, I can do. Okay. So that is where you need to know what should be your first command. And as long as this is running, your container is also running. Because now if I say exit, this command is not running. So obviously there is nothing running inside this container. The container gets stopped. Okay. So this is the basic logic. Now watch this, for example, the same. I'm just going to give a command called echo hi students. Now what happened here? When I run this, we didn't go inside the container at all like this, right? Why? Because first, what is the command you are running? Echo. What will echo do? Echo will just print something on the screen. Okay, it did print. What after that? There is nothing else. And echo command is also completed, and that is the reason it is not even allowing us to go inside the container, and the container is now stopped. Because the logic here is there is nothing running inside the container, so the container gets stopped, and obviously nothing is running, so it will not also allow you to do any attach, because echo is not an interactive command. Echo will just print something on the screen. If I just say echo hi students, okay, as simple as that. So this is how whatever the command that you are running should be a command which should always be running inside the container. So that is where for now they have made bin bash as the default command, which is an interactive shell. So when you run, it will receive the user's input and you can see this will be allowing you. However, as we move, we can change this to run some application. But the logic what I'm coming through is as long as something is running inside the container, your container is called as running, because inside this, if it's a process, then your container is also a process. If there is no process running inside it, obviously the container will get stopped. So that's the benefit of Docker. Because when you don't have anything, why do you need unnecessarily a box running? Getting the point on how you can basically pass your own command and what was happening inside and how we were actually able to connect to it. And typically, if there is any container running, if you want to stop, then you can also go ahead and just say the same by saying docker stop. Okay, so for example, let me just say docker rm test 00. So I'll create a new container. Okay, for example, I will come out and it is stopped. So I'll just say docker start. It's running. If you want to explicitly stop, you can say docker stop and the container ID or the name. Nothing is running. Okay, so this is how you can start your container, stop your container, delete the container. But eventually remember, when you're creating a container, you need to give what is the image, what is the startup command, and what is the name, and do you want to interactively connect to it. Okay, just to show you, these are the options that we have.
Yeah, Adam, I have a question. Like, can we like duplicate names? Will it allow? Because like we have already created with the test. Oh, yeah, it will
not
not.
allow.
It not allow. Okay.
After starting the container, how can I, if I start container manually, docker start container name, how can I go inside the container after starting?
Docker attach.
Oh, got it. Yeah, got it. And one more question, that created container contains OS and everything, right? It's CentOS, whatever the image we supply. So if I come out of the container, if nothing is running, the container will be stopped. Does it mean the OS and other processes also stopped inside the container?
Yes, the entire process itself is stopped.
Then stopping OS, it can be taking some time, right? How come that much quick
It's not the OS. That is what is
Okay.
the difference. It's not a complete OS. Okay, so it has everything the OS needs other than the kernel. Okay, because only when the kernel is running, you need it as a separate OS. So in Docker, the concept is the image has the OS files other than the kernel. So the kernel will be taken from your host machine. So that way it's not a full OS. Because if you have a full OS, then it becomes a VM. That is what is your VMware. And that is when you work on VMware, you have to, work on virtual machines, you have to stop and start. In fact, your AWS machine is also a VM. So that is the reason you are stopping and starting. But here, it's just contains the files of the OS without the kernel.
Got it. Yeah.
Okay.
Adam, can
Adam,
we
I have a doubt.
Adam?
Yeah,
Adam?
go ahead.
Yeah.
Yeah, go ahead.
You have start, stop, and exit. Do you use? Can you have a pause? Can you pause
No,
it?
you don't have a pause.
Okay. Thank you.
No, you don't have a pause. A process cannot be paused here directly.
Okay.
Like
Right, thank
Adam,
you.
always
Yeah,
it's going to be only stop and start status. There is no other state apart from start and start.
If a container is available, then you will have only start and stop. That's it. If not, the container is deleted. That's the meaning.
Okay.
So, Adam, while we are creating the container, so that time, can we put this container for permanent running mode?
Yeah, we'll get into that. Now, this is just one option that I'm
Okay,
showing you to familiar. We have a lot of other things to learn.
okay,
Uh,
thank you.
Adam, one question.
Yeah.
So I have created a container, and after creating container, I have created database in it actually. So the database has some problem. It requires some kernel change, as you said. So that means I have to change the kernel at EC2 instance level, right?
Yeah, if it is taking up the host machine, yes, but if it is more of a OS libraries that you are picking it up, then definitely you have to change that inside your container or use an image which has that particular libraries available.
Okay. Okay. So it will not affect other containers, right? The only one
No.
container requires some kernel change.
See, if you are doing to some library available inside your container like a box, then only that container is get affected or modified. But if you do anything on your host machine, then all the containers running on that will be referring to the same OS, right? So that way it will be just kind of getting affected. In the sense, kernel will get modified there. So that's all. If it's within a box or a container, then only that container gets the result. If you are doing something on the host machine and if it is being accessed by all the containers, then definitely all the containers will also see the change.
Okay. Okay. Yeah.
Adam, question for you. Is the stop and the exit command the same?
No. Stop, you are forcibly stopping the container. Exit, you are coming out of that command. Okay, now practically, if you are running a command which is not bin bash or if it is not the first command, then by doing an exit there, you are just coming out of that container, but that doesn't mean the container will be stopped. Now, why it was stopped so far is the default command that we are running is bin bash, and that is the only command in which we are seeing exit. So obviously the container is also getting stopped. I'll just show you another way where even if I do exit, your container will not get stopped, because if you are not doing an exit on the parent, that is the process ID 1, then your container will not get stopped. So exit is just a, see here, what happens when I say exit here? It goes to my parent shell. That parent shell is Ubuntu. So that is how exit is just a command to tell your current process to stop. That's it. But if your current process is the parent process, then you're coming out of your machine or your container.
Clear, thank you.
Yeah,
Adam, I
I
have
have a question.
Yes.
Yeah, I have one question, Adam. It's like because one EC2 Ubuntu instance we have created. On top of that, and we have created several containers, which is CentOS, Linux, and AX. We have created SunOS. And when we run the check, it's vulnerability verify. It's security check. If we run it, and where can we? It's like because if it is a kernel level parameters, if we need to change, like means and the whatever the container it's OS contain and their kernel level parameters, if we wanted to change, where can we change?
So for vulnerability check, you are not going to do anything inside the container. Okay, so whatever the container is going to have will be available in the image. So when you are creating an image, you are going to validate for all the vulnerabilities in the image itself. Okay, so when you
Okay.
try to run your containers, that is more of what you do is your penetration testing or your general functional testing you will do. But before even accessing your application and running container, when you create an image, you can do a scan on that.
Okay.
Okay, we will get into it. So as of now, I'm just coming to just a first concept. We have other things to do, but anyway, I'll show you that.
One last question.
Yes.
What are we actually doing when we start a container? Are we again running that first command?
We are
Like in
not
this
doing anything
start
as
the
of
step?
now.
In
Not
this.
doing as of now. we are running only bin bash. This was just to show you. Now this is where I want you to start getting into the next one. So now let's take this shell script, whatever I have written here. Okay, so this is a small shell script which is going to be on an infinite loop where for every 8 seconds it will be just printing my name. Okay, this is just to show you. So wait for 8 seconds, it'll print my name. Okay, fine. The only way if I have to stop is I'll do a control C. Okay, now why am I picking up this is, what if I run this as my first command? What will happen?
It will print hello Adam every after 8 seconds.
So this is how I can run this. So instead of a bin bash, now if I want to run some command or an application, I can give that. Now right now we don't have any application, so keep it aside for some time. What I can do is I can run this. So this way, this is a command which will be my first command. So when you go inside the container, what will be the process ID of your container? The process ID of this command is 1. So as long as this script is running, your container is also going to be running. Okay, now this is where the question that comes is, I am not interested to go inside the container. Okay, my interest is to run this, because so far when we used bin bash, because of bin bash you were able to do interactive. But if I run this command, okay, is it interactive? It's actually not interactive. Whatever I type is just not even received by that, right? So that is the reason this command, if I run, it is not an interactive command. So when I give this as my first command, and when I try to say -it, it will not allow me to do interactive, because you need to choose a command which is interactive, only then it will work. But still, my interest is not to do this. Now this is where, if you try to create a container and you want to run some application or some script like this, wherein your interest is just to run that. Okay, because now in an organization, like I was telling, if a developer wants to test something or QA wants to test something, then you just need a container to be created, and inside that some applications should be started. Now that is where, if you choose your first command to start your container and run that application, then you will not be able to do interactive way of connection to it. Now that is where, what will happen, if you give interactive, it might get stuck to this process and you have to forcibly stop. So that is where there is another mode of creating a container which is called as detached mode. So whatever that we have seen is attached mode, there is another one called as detached mode. So what is the meaning of detached? So detached means you are not interested to attach the container to the screen, but do the remaining things. That means start a container, and in that run this first command and leave it to the background, so that as long as this first command is running, your container will also run. And that's where you can go ahead and add this option called -t. So in practical, 99.99% you are going to use a container to run an application. Okay, so in that way, what will happen, you will always give a container in a detached mode, so that the container will be just running on the background, and in that, whatever the first command that you are given will be running. Right now I don't have anything to run inside, that's the reason I'm just giving you a script. So if I go back here and if I just run this, you can see it immediately came out. Does it mean that there is no container executed? So you can see that there is a container running. How? Because inside that, do you see there is a first command running? So as long as this command is running, the container is considered to be running. So that is where when you are creating the container, if it is just for your testing purpose, you use -it. But if you are creating a container to execute an application or a script, then you're always going to give it as a detached mode. Okay. Where did we use bin bash and loop? I didn't use bin bash and loop here. So I'm trying to tell, use sh, and in this sh, you run this as the first command. Okay. Because if not, the while loop itself, see, you're trying to run a shell script. So instead of creating a script and running, I'm just trying to say in one command, this shell will have all these things as a sub command to it and running it. Okay. Now, this is when the question now comes is, okay, container is running in the background. Okay, I understand. That is because you gave some startup command and you told to run it as detached, so it is running in the background. But how do I see what is happening inside it? Now this is where you can say docker logs -f and the same way of container ID or the name. Okay, so now if I say docker logs -f and the container, you can see inside the container, whatever is running, it will give you a live stream on your screen, but still it is not attached because I don't want to attach. So whatever is going to run there, it's going to be displayed. Okay, but still, if I stop this, nothing is going to happen to the container because container is running in the detached mode. Okay, so this is how you can create a container in the detached mode and you can see whatever is running is fine or not. Okay, but still there might be some requirements in which you want to go inside the container, but I cannot use the regular attach because when you say attach, it will try to attach to the first command. Now, can you do an interactive shell to this? It is not possible. So that is when in Docker, there is a command called docker exe, wherein you can give a container ID or a name, and you can give a command of your interest. And what will exe do? Without going inside the container or without attaching to the container, it will execute the command. So for example, if I say docker exe test 00, let me just run this command, then without attaching to the container, it will directly execute this. So that is how, when you have a detached container, if you still want to run something without going inside, you can do the docker exe. Okay, so you will use the -it only for some testing purpose. If not, usually it will be detached. So see, now if I can just say docker exe and test 00 and ps. So now look at this. Inside this container, what is the first process running? This process. So as long as this process is running, your container is considered as running and it is safe. So I can run any command that I want here. For example, I'll just do apt update. Okay, I don't know whether it is yum update. Okay, so the container that we had was CentOS, right? So obviously, I'm just trying to run the packaging manager, which is yum. Apt is only for your Ubuntu. So now you can see this is still running. So this is where, without disturbing your container or without going inside the container, you can safely execute the Docker attach. Right? So I don't need a Docker attach to be executed. I can just say docker exe and it will run the command without attaching to the container. So remember this. This is what you're going to use, logs and exe. You will use it a lot of time. Okay, but still, there are some cases where I want to go inside my container. Then there is a hack that you can use, which is where you can use the interactive option. So when you say docker exe, if I say -it and then the first command has been bash, so it will run this command. But as soon as it runs in an interactive way, you will be attached to the container. Okay, so that is how, if you try running this docker exe -it test00 bin bash. Now watch this. You are inside the container, and what is the parent process ID of the container? 1, and this is the command running, and you have attached to the container using bin bash. And what is the process ID of bin bash? 84, which is not the parent. And here, if I say exit to come out, what is that I am stopping? I am stopping the bin bash alone. And if I stop this, is there a problem to this? No, it is still going to run. So that is where you can safely go inside the container, safely come out, because you're not disturbing the parent process. Okay, so the earlier reason why it was stopping, because when we created a container, the default command was bin bash, and the bin bash was the process ID 1. So when I did the exit of that one, your container was stopped. But right now, what did we do? Already container is running. Inside that container, we are trying to run a new bin bash, and we are going inside it using interactive way. Okay, so that is how you can see it doesn't have any problem. So that is when we executed the bin bash here, the default command was bin bash. Because of this, the process ID of the bin bash was 1, and when you did the exit on that bin bash, the entire container was stopped. Whereas now, if you are running a container in detached mode, this is the first command, and this is what is going to have the parent process. When I do a docker exe and run another bin bash, this is not the parent command. So if I do a exit on this, safely it will come out without stopping your container. But for any reason, if I stop this process, then what will happen? Your container will get stopped. Okay, so that is how the difference between exit and stop. So exit here is just stopping your current process. If that current process itself is the first command or first process, then your container will also get stopped. If not, you are just stopping only that process. Okay, clear so far?
I'm confused between detach and exe command.
Detach is going to create a container and run it in background. Okay, so that you don't want to attach to it directly. So if you have a container which is detached, you cannot go inside directly. Okay, that's the logic. But what if you want to run some command inside the container? Then what will you do?
Okay.
You cannot use attach, because attach will work only on a interactive container, but you have created a detached container. So you want to run some command, but still you don't want to go inside. Then use docker exe. But when you are using docker exe, what is the concept? You are telling run some command wherein without going inside, run something. That is what you are saying. But ideally, there is a hack where if you are going to use -it during this command, this execution will be a interactive. It is not attaching, but it is an interactive execution. Then what will happen? Automatically, when you run bin bash using exe, that shell will be interactive. So automatically it will leave you inside the container. You are not attached, but you are inside the container. But anytime when you say exit from this, only the bin bash will be stopped. Your parent process will still be running. Got it?
Hi Adam, I have a question. Actually, in detached mode, we are executing some commands. So, can we see those logs, details in the logs?
That is what Docker logs was doing, right? Docker logs -f and give the container. This is what is the logs which is running inside the container.
No, actually,
because you're not able to go inside the container.
Yeah, actually, we updated something, right? Like VM update, like we are updating some applications, like updating. Can we see those details in the logs as well, right?
No, that will not be there because those are just command prompts, or right from the command prompt you're executing. So that is where you try to understand that I gave it from my host machine. So if you have a log on your host machine, then you can try to see what and all commands you have executed. Yeah, there are options available to see that, but within the container, you cannot see that.
Hi Adam, I have a small query.
Yes.
Yeah, I have created one container, and under the images I created, running to the container or images. Unfortunately, the container or images is missing or deleting. How can I back up to those?
Okay, there are two things you are saying. Image is separate, container is separate.
Yeah. So
So
both are
is
separate,
your
but
question, no, you created a container, but container is missing, what you have to do? Is that the question?
yeah,
Or within the container, you had some data, you want to take a backup of that? What do you want to do?
yes, yeah.
No, which one? Do you want to take a backup of the content of your container, or you want to recreate your container?
Backup.
Okay,
The
that
data
we will
backup.
see it. Yeah. So there is other concepts. That is what I was telling. There is something called as volume mapping, port mapping. I'll talk about that.
Yeah. Okay. Thank you, Adam.
Yeah. Today I'm just showing you the basics on how do you create a container, start and stop, and what is the internals of your container. Okay, because as you move forward, when you run something like this, you should be clear on what exactly is happening, why you are doing it. Okay. So clear on what happens when you create a container, what is running inside, what is that you're actually starting and stopping, how do you go inside a container, and most of the time, as I said, you will be running everything using detached. But even when it is running in detached mode, you can go inside the container using Docker exe. However, if you stop this, only that process is stopped, not your container, because this is not the first command. But if you stop this command for any reason, then your container will also get stopped. Okay.
Adam,
Clear?
Sushant here. Yeah, hi, Adam, Sushant here. So Adam, suppose we're running one application in one VM. So due to some issue, we stopped that and we restarted one more VM. So that VM ID will get changed and the container ID also will get changed, correct?
If a container is recreated, the container ID will also change. As long as the container is just stopped and restarted, the ID will not change.
Correct. So suppose the old VM also got stopped. So we have restarted one. We have created one new VM and we deployed, but we want to see the old VM log. So if we'll restart old VM, that log will be there, or it will that VM ID will IP ID will get changed.
No. Are you talking about VM or container ID?
I'm talking about the whole machine, IP as well as container. See, if we'll restart one new VM, and we'll deploy. Suppose we are running one application, so due to some issue, we have to stop that EC2 server, and again we need to create
Okay, so
one
you're
EC2
asking
server.
about AWS. Okay, in
Correct.
AWS, yes, every time you Prashant,
Adam, your voice is not audible.
It's not
voice
audible,
is
Adam.
your
Yeah,
voice is
Yeah, your voice is breaking.
breaking. I got your question. So when you create a machine, okay, in AWS machine, when so if you see this correct, every machine has two types of IPs, public IP and private IP. Okay.
Okay.
So
Okay.
every time you restart your machine, your public IP will be changing. And based on that, if you have this public DNS, this will be changing. So as an organization, if you want to have a single IP every time you want to, guys, can you mute for a minute, please? So every time if you are restarting your machine, if you want to have the same IP, then there is a concept called elastic IP in AWS. Okay. You have to enable it. So I'll show you when we go to Terraform how to do it. Okay. So when you do this, what will happen? No matter how many times you restart your machine, you don't have to refer to this IP. There will be additionally a new IP called as elastic IP, which is fixed. And every time you can use this. Right now, if you use this elastic IP, it is going to be chargeable for you. Okay. So that's the reason for us. It's just one machine. So stop and restart with whatever is the new IP you can access. But yes, in an organization, you don't have to remember the IP here. Instead, you fix elastic IP so that how many ever times you stop and start, it is going to be the same one. So that is what you are going to use.
Oh, okay. So no need to go to other IP for if suppose tomorrow I want to go to old log. So if we are new container will restart, so the old container ID log will be there in that same IP, correct?
Okay, now again, you're jumping into two things. A machine is separate, container is separate. So what is the question now? Is the question you are asking now is you have a container, it is stopped, and you want to see the log of that container, or is it a new container you are referring? I mean, there are two things. Machine is separate, container is separate. What is that you are referring to?
No, in same machine, old container log.
Okay, what happens is, yeah, okay, probably I'll tell you this tomorrow. Just remind me. Okay. So when a container is there, the files of the container will be stored in the host machine. So which is the same thing someone was asking backup, right? So it will be available on the host machine. So as long as that content is available, you will be able to retrieve. If not, you need to do something called as a log management, where you should be storing that into a different location, which is what probably sometime at the end of the course we will be talking about something called as Elasticsearch, Fluentd, and Kibana. So you are going to store everything. Or if your company is using some tool like Splunk, you can upload all the logs to that. But without all those things, if you have a backup available on your host machine, you can go back and see. Okay, I'll talk about those files, where it is, how it is accessed tomorrow.
Okay. So, okay. Thank you, Adam. Got it.
Okay,